This demo shows how we apply our game AI approach to the process of designing well trajectories. This application demonstrates how AI can truly redefine multidisciplinary workflows in oil and gas, transforming speed and quality of the decision-making and changing the underlying team dynamics and behaviors. Designing well trajectories involves a number of technical disciplines, each using their own software. Value drivers, risks, constraints, and opportunities are expressed in different terms and are not easily comparable. Team dynamics are impacted by these functional silos, and the process often becomes iterative and time-consuming. In many cases, the team does not have the ability or time to explore the full option space and to really understand pros and cons for each option. The preferred well trajectory therefore needs to be selected from only a limited number of options, after significant time and effort. In such a situation, how confident are you that the decision is of good quality and no value is left on the table? In our game approach, we use an AI assistant that learns how to construct well trajectories for any set of inputs, value drivers, and constraints. The game includes key elements and rules such as geohazards, faults, target locations, remaining oil estimates, design constraints, and collision risks. The game is played by the AI assistant, which learns itself to construct well trajectories, seeking to maximize reward and avoiding key risks. We then analyze the results and use that insight to test alternatives against different subsurface interpretations, new value drivers, or updated risks and constraints. This demo of Whitespace Navigator, our AI-assisted well trajectory planning solution, is based in Equinor's Evolve dataset. Our approach is extremely flexible and can accommodate inputs from any source, such as static models, dynamic models, spreadsheets, seismic interpretations, well surveys. All these inputs, representing interpretations of rewards and risks, are combined in a modular three-dimensional grid. Using this grid, Navigator then screens feasible well trajectories from a particular surface location, very much in a similar way as a self-driving car is teaching itself to navigate through a busy city. Honoring all engineering constraints, the AI assistant seeks to maximize reward while minimizing risk and avoiding hard constraints such as existing wells. Within hours, Navigator screens hundreds of thousands of feasible well trajectories. The full option space can then be visualized and analyzed by the team in bespoke and collaborative dashboards. We use data science techniques to cluster the hundreds of thousands of feasible well trajectories into a more limited number of archetypes. These archetypes are then displayed and analyzed for a range of parameters, such as total length versus reward and well engineering complexity. The integrated team can quickly determine which parameters are critical for another iteration or whether a different set of subsurface interpretations is needed to test robustness of the preferred option. Our experience is that Navigator truly transforms team dynamics. The full transparency of the option space, the collaborative dashboards, and the integrated reward grid give the team a much better understanding of each other's drivers and concerns. The speed and dynamics of the application inject fun and enjoyment, and enable the team to fully explore robustness and range of uncertainties. The team is much more confident in making a final decision, knowing that all options have been explored and associated risks and rewards are understood. Whitespace Energy, navigating complex decisions in oil and gas through game AI.